Hi, this is an overview of the Lab 3, which is going to provide some structure around writing SQL queries. This is pretty much the same process that I've tried to follow every time when I've discussed queries earlier, but we list out a little bit of structure around writing single table queries, join, and subqueries. So the basic format that you're already aware of starts with a select clause, but keep in mind that the select statement is interpreted or executed at the end of the code and not the beginning. The from clause is where we specify the source of the data that we're looking at. So the table names, if we need to do a join, or if we need to set up a subquery there to give you some results that you'll use as a table. Once you specify where the data is coming from, you have to look at whether you need to remove some rows from the output, which is where you will use a row level filter, the where command. Once you have removed the rows that you want to take out, then you have to ask yourself whether the query requires you to group by any particular attribute or a collection of attributes. So the group by will create groups on the attributes that you specify, and usually required when you have some kind of aggregate function that you're looking at. Once you create these groups, then you have the option of filtering those groups. So typically the having clause will use an aggregate function to create that condition. And once you have filtered those groups, you are free to order them. You will need to use the order by clause for ordering rows, because SQL by itself does not inherently have the rows outputted in any particular order. So the from clause specifies where the data comes from. The join commands will also appear here, but we see that in a subsequent query, not in this one. The where clause, as explained, is a row level filter. So for example, if you want to list only those products where their price is less than 10, you need to look at a row level condition, because you're removing products which is one row is one product where price is less than 10. The group by clause, which comes after you have filtered the rows, again will group by the commands, and the field names that you are using in the group by will decide the kind of collections that are made from the rows that are left over after the where clause. If you use multiple columns in the group by, you will get unique values of 2 or more columns combined together to be used for the group by operation. So once we have a group by clause in there, the most likely use of that is to do some kind of aggregate functions on your output. Sum the values for a group, average, minimum, max. While you can use aggregate functions for the entire table, most of the time they are much more useful when you start aggregating for groups. There are a couple of rules to be followed when you start using aggregate functions and the group by statement, which you can review from the notes. Once you have these groups formed, the next condition that's available to you to filter the rows is with the having clause. So the where clause does row level filters, and the group by clause groups them, then the having clause filters those groups. Let's look at an example from the illini.mdb table where we need the total number of turnovers, that's the output I need, by players who played in the game for more than 10 minutes. That's one condition. But I want this only for games with more than 10 turnovers by these players. So let's look at it. First of all, we know that the data is coming to us from the game stats table. The illini.mdb data file has the games, the game stats, and the players t table. Here we are only looking at game stats, so there is no need for a join. So first of all, we want players who have played for more than 10 minutes. Remember, game stats is one row for each player, stats for one game. So if we want to remove players with minutes less than 10, that is a row level filter. So we are filtering rows from our output where minutes should be greater than 10 and leave out the others. So that becomes your where clause. Once we do that, we decide on how do we need to group the rows. The total number of turnovers by a player or by players is for each game. So one game, all the players who had more than 10 minutes, we need to add up their turnovers, which tells us we need the sum function for each game. So the group by will happen for game ID, and the aggregate function that we use is going to be sum of turnovers and not count, because we need to add the turnovers across all the players for each game, keeping in mind that we have already removed players who played less than 10 minutes. Finally, we've removed the players who had less than 10 minutes. We have grouped by game. We know that the sum of turnovers will give us total turnovers for each game. But we want to keep only those games where the total turnovers is greater than 10. That is where the having clause helps us, because we have groups by games with the sum of turnovers, but we want to keep only those games, i.e. the groups, where the sum of turnovers is greater than 10, which is where the having clause helps us. And finally, putting it all together, we get, give me the game ID and the sum of turnovers. You can leave out the sum of turnovers if you don't want it, but from game stats where minutes are greater than 10, which means only players with minutes greater than 10, group them for a game, add up the turnovers for each game, give me games with turnovers, total turnovers greater than 10. So the order of execution: from, where, group by, having, and finally we go back to the select statement to output the result of the query. So all the processing is happening in line 1, in step 1, 2, 3, 4, and then going back to step 5 to output the results. So let's look at another example from Northwind database where we want to list the customer ID and the total number of orders placed in 1998. So in the northwind.mdb table, we want to find out, for each customer, list the customer ID and the total number of orders placed in the year 1998. First of all, we know we are looking at the orders table, as you can see from the diagram ahead. We want to count now the total number of orders for each customer. The for each word specifies to you the fact that we need a group by, because one customer has many orders. So we want to group by customer ID and then try and count the number of orders for a specific date or within 2 specific dates. So we know we need customer ID and we are looking for some kind of count. So keep in mind that the customer ID is stored in order table as well. Since all we want is customer ID, we may not need a join. So when you look at the filters now, we want to include only those orders where dates were within 1998. So if you look at orders table, we want to filter out by order date and group the rows by customer. One customer, many orders, count them. And we don't need any particular order, and we don't need to leave out any customers. So we don't need a having clause as well. So the final result there would be to give you the customer ID from orders with orders between a certain date, group by customer ID. So now let's move on to some joins and subqueries. While working on such problems, it's best to break up the question that you have. So let's look at some questions that we answer when we are looking at joins and subqueries. So again, back to northwind.mdb. List the order number, order quantity, and product name. So that's your output for all order lines in which the order quantity is greater than the average order quantity of that particular product, not the overall average. So first component, output, that is your select clause. Then for all order lines in which, suggesting some kind of filter, could be in the where, could be in the having as well. We'll keep track of that. So we've separated out the parts. The order number, order quantity, and product name is my output. Order lines in which suggests I need a condition where the order quantity is greater than the average order quantity for that product. So keep in mind, it's not an overall average of all products. It's an average of the particular product itself. So we have seen this example earlier. So which tables do we need? Order details and products. Let's go back to the northwind.mdb and see whether that meets our requirements. So as a reminder, we want order number, order quantity, and name of the product. Okay, order number, quantity, and name. So when you go back to the Northwind table, you see that the order ID and the order details have this order ID attribute. The product table has your product name. So we may not really need the orders table because we have order ID in the order details itself, and all we need is the product name. So we need products and order details. Let's go back to the query. Order number, quantity, and name, product name. All of these things are available in order details and product linked by the product ID. So let's look at what the join will do for us. First question, what kind of join? Do we need an inner join or an outer join? Inner join if you're only looking for common elements or common values between the two sets or tables that you're joining based on a common field. If you're looking for all the rows from a table and only matches from the other table, you're looking at some kind of an outer join. Whether you do left or right is a decision that you make. And always while you're doing the inner join, you're keeping in mind which attribute is common between those two tables. So here we have product ID, that is the primary key in the product table, and a foreign key in the order details table, which helps us do the join in these two tables. So remember, the join as a process will create a new set which contains all the attributes from these two tables. You know, you can keep in mind the relational algebra operators of how a join really works, where first it does a product, a Cartesian product, then it does a select where it matches rows with common values on the common column, and finally does a project, which is give you columns from that output. So you can review relational algebra to understand what all happens within a join. So finally, the second part of the query was the order quantity needs to be greater than the average order quantity of that product. So for every order, there are multiple lines, and we want to filter out only those orders. We want to show only those orders where the quantity ordered was greater than the average order quantity of that product. So we know how to do the average of a particular product, which is simple. Select average quantity from the table where product ID equals whatever product you're looking at. But the trick here is required to that how do we compare this average for a particular product when we are listing out the results of this query. So this will require a subquery or a correlated subquery, and we'll see in a moment why. So we want order number, order quantity for all customer orders for which, that's where we need a condition. So this is a where level filter because we want to look at orders in my order details table, each order line, because we are doing by product, we are not doing by order. So we want to list products or list orders where products have been ordered more than the average order quantity for that product. So it is a filter on the lines, but we have to run that filter using the query that we have looked at here, comparing it with the average. So let's look at that. So this is what the query looks like, and let's explain it. So the select is your output. You can skip that for now. We know we did a join between products and order details, so that's done. The where clause is where we are doing a filter. So we are looking at orders or orders with products where the quantity ordered is greater than the average for that product itself. So notice here the subquery which says select average quantity from order details seems okay, where the product ID equals products dot product ID. So note the reference of the inner reference from the inner query to the outer query, because products dot product ID is not declared in the inner query, it is only declared in the outer query on the from statement. So this tells you it's a correlated subquery. But why do you need it? Because we want to keep track that the average quantity that I'm calculating has to be for the same product that I'm talking about in my outer query. That's why you need that link. So as far as joins are important, we need to keep in mind the use of inner join vis-a-vis the use of outer joins. Also, it's useful to remember both formats of the inner join, one where you use the join command and the other where you use the where command to set up your join conditions. As you have seen a couple of examples, it's also possible to do joins with more than two tables. It's just that you have to nest the join statements. For every n tables that you join, you will need n minus 1 join conditions. So if you're looking at 3 tables, you must have two join conditions on the common columns. And remember that you need to use prefixes for those column names. If for sure if they are same column names, but you know that they can be different as well. So if we look at this example, this is a 4 table join between customers, orders, order details, and products. You have 3 join conditions specified using your where clause, and finally another filter with the last statement which lists all of this information, which is essentially customer name, order details, and the total value of your order for a particular order from your table. So that is order 10260. So this is one format of your join, and you can do the other one as well where you use the join command explicitly. So let's try and interpret a couple of correlated queries to see how we recognize them, how we interpret them. So this query starts out from products. Notice the alias P1, and we seem to want only those products. So we're saying where P1 dot product name in something. That means the inner query must result return a set of values. Let's look at the inner query. It says select product name from products, the same table referenced with another alias called P2, where P2.productName equals P1.productName. So two aliases for the same table. Think of two copies, one is P1, one is P2, but they both point to the product table. So we are comparing two copies of the product table, looking at the first row from product as P1, comparing with all the rows one by one from product as P2. If I find that the first product in P1, once that's picked up, I compare that with row by row with product names from product as P2. If I find a match, on whichever row I find a match, I look at the other condition where the supplier ID in product as P2 is not equal to the product as P1 supplier ID. I output the name and supplier. So remember, the correlated query executes one loop in the outer query and then runs through the inner query. So here, with one product from product as P1, we compare with all the products in product as P2, and then wherever we find that the supplier IDs don't match, we output that row and then go on to the second product in product as P1. So essentially we are finding a list of products which have more than one supplier, because we are matching the products but finding where suppliers don't match. And that is a correlated query, and we can see that because in the inner query we are referencing the outer query. So for example, P1.productName is a value that's available from the outer query, and the same goes for P1.supplierID. So this demonstrates the flow of execution as I have just listed out for you. So keep the flow in mind that the outer query starts, one value is kept in the outer query, and then you cycle through all the values in the inner query. Then it goes back to the second row in the outer query, then run through the inner query all over again. So final result, the list of products with the same product name that have more than one supplier. So try this in the northwind.mdb database, and if it does not return anything, add a row in the product table which has the same product name but a different supplier, and see if the query gives you an output. Another useful correlated query to interpret is when you use the exists clause. So read this for a moment. We are trying to find product name and supplier ID from products again. We created the same alias P1, but now we're saying where exists. And remember, the exists command looks for a logical value, true or false. That means the inner query or the subquery here, if it returns any result, the keyword any is important. If it returns any result, exists will evaluate to true. If it gives no result, exists will evaluate to false. If exists evaluates to false, the where condition becomes false and nothing gets output. So again, a row by row comparison, starting with the first row in products as P1, comparing with the products as P2 table, running through all the values, doing the comparison of P2.productName is same as P1.productName, and the supplier ID is not the same as P1. If that gives any result, we output the product name and supplier ID.